Hi, this is an introduction to solving absolute value equations. So for any positive number p and any algebraic expression x, the solutions of the absolute value of x equal to p are those numbers that satisfy x equals p or x equals negative p. So with that statement, I want to go down to the bottom of the slide here where it says solve the following absolute value equations graphically. And the first one that we encounter is the absolute value of x is equal to 2. Okay, so I want to take a look at this graphically, even though we're going to concentrate on solving things algebraically, because I just want to show you why there are two solutions here, right? So it's saying x is equal to p or x is equal to negative p. So in the graph, the blue graph is y equal absolute value of x. The red graph is y equal 2. Okay, so if we say absolute value of x equal to, we want to know where those two things intersect, right? So I'm just going to put a couple of dots on these intersections, right? Right here and right here. Okay, what are the x values where that happens? Negative 2 and 2, right? So the solution set is negative 2 and 2, right? Okay, so now let's think about that just logically for a minute. So if we stick that back in to check it, the absolute value of 2 is 2, right? And the absolute value of negative 2 is also 2, right? So that's another way you can reason it. So both graphically and numerically, we can see why that's true. So as we're solving more of these, you may have something inside the absolute value signs other than x. There might be a whole algebraic expression there. But if we just think about the fact that it could be positive or negative, then whatever number that's equal to, just make it positive or negative, and you're solving two equations, really. Another element of this, if we look at part B above here, so it says the equation absolute value of x equals 0 is equivalent to the equation x equals 0. So down below, I have that the absolute value of x is equal to 0. If we look at that graphically, the absolute value of x graph touches the x-axis right at the origin, right at the point 0, 0. So the x value that makes the absolute value of x 0 is 0, right? And the absolute value of 0 is 0 too. We could also think about it that way, right? So the solution set there is 0, okay? Now, again, if we didn't have just x inside the absolute value signs, if we had, 3x plus 7, then we would set that whatever that expression was equal to 0 and solve it. Now, the last thing I want to talk about is what happens when we set the absolute value of x equal to a negative number, okay? So the equation absolute value of x equal to negative p has no solution. And let's look at why. So I've got an example of the absolute value of x equal to negative 2. Okay, so we've got the y equal absolute value of x as the blue graph, and then y equal negative 2 as the red graph. Do they ever intersect anywhere? No, they don't. So it's the empty set. There's nothing in it. Okay, also the other way to say that that's completely acceptable is to just say that there is no solution. There is no solution. There we go. Okay, so hopefully that makes sense to you because the absolute value has to be a positive number. So if you have absolute value of anything equal to something that's negative, that should be a red flag. That can't be, right? Okay, great.